So, welcome to this lecture on formulating linear programs. In a previous video where we're looking into what linear programs are and how we can solve them graphically, and now we're going to look into how to actually formulate them mathematically. So we're going to use the same example, the example of a barge that ships sand and coal. And just to remind you, we have this barge which can transport sand and coal at revenues, and we have a few constraints. So we have a capacity constraint, we have a coal availability constraint, and we have a loading time constraint. Now let's generalize this a little bit. We have a barge that transports different goods, which we refer to as K and K. So this K could, for instance, be sand and coal. At revenues RK from Antwerp to Rotterdam. So for instance, if we look at the previous slide, at this example, this could be the 100 euros per ton and the 150 euros per ton. Then we have a total capacity of U, which on the previous slide was 225 tons. Then we have an availability, which is AK of good K, which on the previous slide was only given for coal. But if we look at the total capacity, we would also be able to say sand, there's only 225 tons of sand available because we cannot load more anyways. And then loading, 1 ton of a good K takes some time, which we denote by TK. And in total, the barge must be turned over in time T, which means that we have to load everything that we actually want to ship from Antwerp to Rotterdam within this time T. So, how are we tackling this? So if we want to have a linear program, we're always following this recipe. So we're first identifying the sets, then the parameters, then the decision variables, then we formulate the constraints, and then we formulate the objective function. So let's look into what a set is in this particular sense. So here, a set is the type of commodities. So in this case, K could be coal and sand. But in theory, we could also ship a third commodity. Then we're identifying the parameters. So in this case, we have revenues, RK. We have a capacity of U. So we can ship at most U items in total. Then we have available material, which is going to limit how much we can ship of a certain type. Then we have a loading time, TK, per item K. And we have a turnover time. So parameters is everything that is given exogenously to the problem. So this is nothing that we can change. So this we just have to accept. Then we have our variables. In this case, the variable is the amount shipped per commodity. So in this case, this is our actual decision. So here, xk can take different values. Then we have constraints. So we shall not exceed the capacity. So all xk must be less than or equal to U. We do not ship more coal than actually is available. So xk is less than or equal to AK for all k and k. We have to load everything within the turnover time. So the sum overall commodities, TK multiplied by xk, so we ship xk items, each item takes time tk, has to be less than or equal to t. And we have no negative shipment volumes, which we also refer to non-negativity or domain restriction constraints, which just say, okay, everything that we ship has to be positive. We don't want to ship -5 tons of coal from Antwerp to Rotterdam. And lastly, the objective function. Our objective function is to maximize the shipment revenues, so over all items. So we're saying, for instance, here we're saying 100 times the amount of sand plus 150 times the amount of coal. This is what this objective function is stating here. So what I would like you to take away from this introduction on formulating linear programs is, first of all, what parameters are, secondly, what variables are, thirdly, what constraints are, and lastly, what the objective function is. And of course, also how to formulate that in general. Thanks.